So we have this situation where we have to integrate x+1 root over 1 plus x minus x square. So you know that this is integration irrational part. So if we will have linear root over quadratic, okay, so in this case we used to take linear as 1 by z, okay, and then your things are done. If you have quadratic and quadratic, you will take x as 1 by z. So can I take z as minus 1, z power minus 1? So who is this L? L is x plus 1. Now do the differentiation both sides. So differentiation of x is 1, differentiation of 1 is 0. Now do the differentiation minus z power minus 2 dz by dx. So can I write dx as minus of dz by z square? Okay, so this is the idea. Now let's do the simplification. Integration of minus dz by z square. So this is your dx component. Now you have x plus 1. So who is x plus 1? X plus 1 is 1 by z. Correct? And then you have root. Okay? So you have to manipulate root. So x plus 1 is 1 by z and minus x. X is what? 1 by z minus 1 whole square. Okay? So this is your things. So this thing gone. So we are left with minus of integration dz by z, and we have 1 by z minus 1 by z square minus 1 and then plus 2 by z. Okay? Now take the LCM. If you'll take the LCM, and this z and the denominator z will be neutralized. Okay? So we have integration of dz by, yes, so LCM was what? So it is root over z minus 1 minus z square and then plus of 2z. Okay. Now this is something which is under the root. So what we will do? We will apply completing the square method over here. So dz by, we have 3z minus 1 minus z square. So we will send that negative inside the root. So we will have dz by z square minus 3z plus 1. You know that you cannot factorize this thing further. So what we will do? We will do the completing square method. So a square minus 2a, the b should be 3 by 2, because if we will take b as 3 by 2, then this component and this component will become the same. Okay, now you know that you have introduced 3 by 2 as b, so you have to add 3 by 2 ka square, you have to subtract 3 by 2 ka square and then plus of 1. Now who is this component? This is z minus 3 by 2 whole square, and then we have 9 by 4. Okay, so we will have minus of 5 by 4. Okay, now can we write this thing as, look, we got dz by root over z minus 3 by 2 whole square minus 5 by 4. Okay, you can write this thing as something square. So can I write root 5 by 2, okay, by 2 ka whole square. Now the point is, you can treat this thing as x. So we have x square minus a square. So you know that inside root we have x square minus a square. So we can apply that idea where we have used, you know that, do you think you are comfortable over here? No. So if we have root na, if we have root, we used to get comfortable with a square minus x square. Okay, so it is with root, we are not comfortable. Okay, so we will be using direct formula. The formula was log, it was log, and then x plus the same component. So who is behaving like x over here? This thing. So can I write z minus 3 by 2 x plus the same thing, root over z minus 3 by 2 whole square minus root 5 by 2 whole square. Okay, plus integration constant c. Now you have to replace your z. So who is z? Z is 1 by x plus 1. So you can replace here to get the desired answer. I hope the idea is clear and you can handle similar situation. Also, sometime what will happen, like if you will take this minus common, you will have a square minus x square. So in that case, you will have answer in terms of sine inverse x by a. Okay, so depending upon the answer, you can choose accordingly. Okay.